Welcome to live stream number 111. 3 ones. My name is Lars Christensen, and thank you so much for joining me today. This Friday, December 22nd, it is almost Christmas break. Off next week, folks. What do we got today? Today, we are going to machine the sprocket that we modeled up yesterday. And we got a lot to get to today. So we got to jump in there. But first, that thing behind me, it's actually running right now. You probably can't see it. It is a Haas simulator. So a Haas CNC machine is just kind of like the controller, kind of like simulating code. It's actually running the code that we kind of like gonna cam up today. So for what it's worth. All right, let's jump in there. We have, like I said, we have a lot to do today. We're not just gonna talk cam. We are also going to talk about cam modeling, because when we get into cam, sometimes we gotta mess around with things. So yesterday we modeled up the sprocket. We're gonna talk about how I model up this sprocket later on, because I got some great comments and questions about that. So we gotta touch that. But what we're gonna do is we're gonna throw some toolpath on it, and I wanted to share some tips and tricks, show you a couple of things. Now first, before we get too deep into this, we kind of like we can break this down into, I would say, 3 different types of toolpath. There is this curved surface here. Remember how we modeled that up yesterday? There is, of course, the sprocket gears going around it. And then there is the center with kind of like this locking pin in here to kind of like hold everything in place. Now, you might be tempted if you're watching other live streams, and there's not, again, I say it all the time, there's no right way. You could go in right in this file that we modeled up yesterday and go into cam, right? Click cam, and now we're in the cam workspace. We could go in and we could start throwing some toolpath on this one. Now, one thing that I quite struggled with when I was working at Ridlam was you would get a model in like this, and sometimes you have a tendency that you want to do as much as you can on the first operation, but then if you have to, like we have to in this case, flip it over, you want to do the last portion in the last operation. So do as much in the first, flip the part over, and then do just whatever you have to do to kind of clean it up. Sometimes that gets confusing when you get a 3D model like this, because well, one of the things that happens is if I, for example, want to machine this surface right here, so we're in cam and I'm just going to do a quick setup. And this is not final, just going to show you something here. I'm going to make that Z go up, and you know, probably also would have round stock for this. So let me just go into rather size stock. To machine this curved surface, see what happens here. If I really want to use the scallop toolpath for this, and I'm going to talk a little bit about that later. Let me just select the tool. I'm going to use the metric tutorial metric library for all this. Select the ball end mill, and let me just hit OK. What you will see that happens is that, I mean, the toolpath is not really bad, but you see how that it follows the outside profile of the sprockets, where I really wanted just to kind of like the toolpath to be uniformed, almost like as if I didn't have the sprockets in there. And that kind of goes back to what happened yesterday when I modeled this part up. Somebody was commenting, it have made more sense to have put that curve on before you put the teeth on. And absolutely, it could have helped me quite a bit. So the way I really would like to machine this part up in cam is I would do it in 2 setups. But instead of trying to machine as much from the beginning, I would actually do just this here. I would put a round blank, and I would actually probably finish the thickness of the blank, what was 14 millimeters. I would probably leave a little bit extra on the outside, finish the thickness to 14 millimeters, have it all lapped in so it's all nice. Then I will do the first setup where I would put it up in kind of like, this is like well, this is actually a chuck for a lathe, but you know, you can put that on a table, right? Put a couple of clamps here. And in the first operation, I would machine this surface, and then I would machine the center with that little notch out there. And actually, I gotta say it again, I have never worked in a shop where we didn't have a wire EDM, so I would actually probably cut all this out of a wire EDM. That way I would never have to worry about corner radiuses in here, internal radiuses. Gonna come back to that a little bit later. Could also broach this. There's different ways to do it. We're just gonna pretend we only have a mill for this today. So this would be my first operation. Then, in my second operation, I am going to throw it in on a kind of a fixture that I create. Now, this fixture is round. It could be rectangular for that matter. All it really is, let me just hide the sprocket for a second. All I did was I created a base fixture. I'll turn some of this stuff on. Base fixture here. It's a little bit of recess on it, so when the sprocket is sitting, it's actually sitting up in the air, so my end mill can go past here. And then I probably would put something in like a center pin that has a screw in the center, have a notch out where a little pin or a little rectangle block could fit in that would lock the sprocket in, and then I would just put a screw and a washer that I downloaded from McMaster. That's probably how I would hold this part if I didn't have a wire EDM. So first operation, just machine this surface and do this cutout, machine the center, machine a little notch out, then go over, and this could be on the same machine sitting next to each other, and then flip it over, do the same kind of curved surface, and then do the teeth, and that should kind of like finish it out. So a lot of stuff here, different ways to attack it. Might be better ways to, like I said, if I had a wire EDM, then that stands for, somebody just put that in there, it stands for a wire electronic discharge machine. I would probably use that. Now, that took 8 minutes. But I thought that was important to kind of like just, you know, we have people here in different kind of levels when it comes to CAD and CAM. So I just want to kind of like say that that's where I kind of like want to end up. Now, I want to make a point that is very important. I would probably not, well, actually I would not for this part here. If we only had to make between, I don't know, 1 to 10 gears, I would probably, or sprockets, I would probably not have this in my model. I would maybe not even model up the fixture in here. I'd probably be able to do all that without even having a CAD file on it, if I was kind of like just bootstrapping it on my mill. Okay, I wouldn't even you know, go as far as having all that in a CAD model. But I felt like it was important to kind of like show you visually what I would do. So what I would do, keep on talking, right? What I would do, let's just forget about these two setups for a second. Gets back to our original sprocket here. Now, this file we got from a customer or from the design department. If we just were making it ourselves, we maybe could get away with just getting into the CAM workspace and start throwing toolpath on it like this. But if we assume that we got it from a customer or something, you know, I would not do all my CAM inside of this model here. And I talked a little bit about the other day when I talked about the 3 ways that I model up. So if you did not check that live stream, check it out. I was talking about, you know, how you can do different things. The problem by putting your CAM toolpath in here is that if the customer ever comes with a change, or the designer comes with a change, design department comes with a change, then it can be hard. You have all these fixturing and work holding, and it can just be a little bit crazy. So what I would do was I would open up a new design, and I know I'm talking a little fast, but I have a lot to cover. It's the last live stream of the year, so if I'm running a little bit over today, I'm not going to worry about it. So I would open a new file. I'm going to save it right out of the bat, and I'm going to call it let's call it our CAM, so we can all remember that that's what I call it. Now I'm going to go out and, well, I could go out and insert our original Sprocket in here, but what I really want is I actually, for the first operation, I really want a part that looks like this, okay? And this means that I'm going to get a little bit into some of the modeling issues from yesterday. Now, again, customer part, design part. I don't want to mess with the customer's file here. So what I'm going to do is I'm going to go up and I'm going to say save as. I'm going to save as a copy out of here of this. Now, I like to leave the V1 in there for the name, because that means that it is the Sprocket version 1 that I'm saving out a copy as. These two will not be linked. So this is going to be my first operation, blank, that I'm going to be using. I'm going to show you some neat things with this. So this is going to be my first operation. So I'm going to hit save to that. Now look up at the name. You will see the name automatically changed. So I now know that I'm working on the one I just saved out as. So the original Sprocket, the one I got from the customer, is sitting down here and is safe. We haven't messed with that one yet. We're going to use that one in a second. Now, here comes what I did yesterday. So yes, there was a couple of things I got to quickly address from yesterday's design challenge. A couple of things. First of all, one comment: if I had put these swoopy surfaces on prior to the teeth, would that have made sense? Yes, that would have made sense. That was just one of those things in the design process. I didn't quite think it all the way through. Another thing I showed you in here, if I scroll back a little bit, remember how I kind of I broke the model into two to kind of get that intersection up here. I got so excited by showing you how you can break your model into section pieces and then stitch it all together again in here. There is actually, if I go to sketch, I go down to project, there is a intersection tool right here I could have used. Now I want to do a live stream specifically on the project tools. I haven't gotten to it yet, but this would actually have saved me from having to cut my model in half. This would actually have projected right where that plane was. So the couple of people who did that, yes, who pointed that out in the comments areas, yep, you're right on. I got too wrapped up in my many times I just want to show you functions, and I guess sometimes that costs a little bit on the best way to do things. And the last thing I'm gonna just show here, because this is important, was I used the revolve or angular plane to create a plane here. Yes, as somebody pointed out, using the mid plane would have been just maybe even a faster solution. So this is great. That I'm kind of happy that I screwed this up. Well, I don't know if I want to say, I'm not admitting that I screwed it up, but there was probably a better way to do this. But it's fine. I'm okay with that. Because that gets me to, this is what always happens in real life. You model something up, and then you get to the point where you got to do something else, like us today with CAM, and then you suddenly like, man, I should have thought of that. But then you got to find ways around it, and luckily Fusion is awesome, so we can do that. So what happens is I want this surface to actually be without the teeth, but because the way I modeled it up, if I go in, you see here we have the circular pattern. If I, for example, go in here and right click on that and say I want to suppress that circular pattern, well, because Fusion is completely history based, notice what happened. Everything else that relies on that circular pattern gets also suppressed. Same thing if I unsuppress the revolve here, and I go back to our original teeth, right click and suppress that feature, then we're back to our original plane. What kind of destroys my thought that I want that that curved surface by itself, because it relies on these two here. It's one of the things that is great about history-based modeling, but also can give you a little bit of a headache sometimes. Well, here's a trick. Inside of Fusion, there's many different tricks, but here's one of them. Inside of Fusion, we made a copy of the original customer files. We can actually eliminate the history-based thing here. And this, I think, is probably one of the best things to know when you're prepping parts for CAM. Because knowing that you can go up here and right-click and eliminate the capture design history tree, literally just eliminate all the things that gets controlled by this. Now, when I click on this, there's no way back. You get a warning. I cannot get my history tree back on this. That's why I'm making a copy. But I get what is called free-form direct editing tools available. So I'm going to hit OK to this, and you will see that my history tree is gone. So you right-click up here and say, do not capture design history tree. Now, I'm not quite sure 100% how Fusion calculates everything, but you will see that it finds some of the features it brings in here, but a lot of them are lost. And because the way I kind of split things up, you will actually see that the pattern is here, but only half of it. So let me just try to delete that. And, well, I got what I wanted. I got half of what I wanted. I still have some teeth over here, but this is what the surface that I was kind of like going for, right? Now, one of the other things that we need to talk more about on these live streams is the different selection tools. So what I actually want to do is I want to delete all these faces here. You can go and hold down Control, and you could go around and multi-select. Zoom in a little. Select all the different faces, and if I delete those, then it will actually get rid of the teeth. I just want to show you how cool Fusion is when it comes to selection. I'm going to go in and say only prioritize. Now, so if you go all the way down to the bottom, here's everything that gets selected right now. So you can see everything is checked. Well, you can actually go in here and kind of like prioritize what you want Fusion to try to select. So if I say select face priorities, the menu goes away. Now see how little gets selected in here, only body faces. And then I'm just going to go up and select freeform selection. And just check this out. I'm just going to drag a lasso around here. Boom. And I just selected every single of those faces that goes around there. Okay? So rewind the video if you want to see that again. I'm going to hit delete. And now I got what I want for my first part here. Now I actually, and to get back again, I just go up here, say selection filters, select all, and go back to window selection, and I'm back to the original one. Now for the first operation, I actually don't want this one down here, so I can select that face, hit delete, and this is actually how I want the first operation to look like. Again, if this is going a little bit too fast, rewind, okay? Now, what I'm going to do with this, you could say, all right, so this was your first operation. Let's start camming. Well, just hold on 1 second. I really only want one file with all my different toolpath on it. Remember, we're going to have two operations. There's this one, but there's also this one, right? So I'm going to save this first operation. And you could say here, you know, made it ready. Whoop, ready for first op. Okay. Always put a note in here. It's going to help you in 3 months when you can't freaking remember what you did. Okay. So I saved this part out as our first operation here. Now, remember that our cam part that I created that don't have anything in it? Now I am going to bring in that part that we just that we just created, that first operation. I'm going to bring it in here because this is also where I'm going to bring in, for the second operation, the sprocket. So what I'm going to do is I am going to right click and say insert into current design. So it's going to come in here. And you always get the first move when you come in here. But I actually don't like to do that because one of the things that can happen in CAM is that the customer do make changes. Actually, that normally always happens. And using this first move, I'm not a big fan of that. I actually like to use joints to kind of like reorient things if I have to. But I'm just going to go ahead here and hit OK. I don't like to use the move copy when I'm doing CAM. Now, I want to show you another trick. Notice up here in the view cube, don't this just make you bananas when you are doing CAM. You're bringing in a file, and whoever designed this dang gear, sprocket, placed it on a weird, I mean, the right plane. Doesn't make any sense when you're doing CAM. Here's the trick for that. Click on the view that you want to be top, right click on the view cube, go down and say set current view to top. Now that part is right. Now we didn't change anything in the file, although we just changed where the camera is. But if you're like me and a CNC guy, top means I'm looking straight down on my part. Okay. Now we got a couple of more things we got to add in here. Here's another thing that is extremely important. When we bring a file into Fusion, look at this. The file are floating around in space. This is not great. I like to use a joint for that because if I got to swap the parts out later on, then, you know, then it's good that you have it kind of like joined in here. Another thing I'm noticing when I'm looking at the top of this is that my key is staying in an angle. All right, so I have a couple of things I gotta fix here. So I'm gonna turn my origin on, rotate my model around. I am gonna go up and hit the inspection tool, and I'm gonna select my plane here and the side of the face. That will give me the angle right there. Now, I could write it down on a piece of paper. What I'm actually going to do is I'm going to double click on this number over here. Then it is copied to our clipboard on our computer. So I'm just going to do that. Double click, and it's now copied. So now the computer remembers that degree because I can't remember what I had for dinner last night, right? So that's one thing. Now, when it comes to joining things together in here, here's probably one of those tricks that if you're coming from another CAD software you're not used to, but in Fusion we can actually join to sketch geometry. What? So what I'm going to do is I'm going to open up a sketch, create a sketch. I'm going to open up a sketch right here on the top plane, and I'm just going to draw a circle. And I don't even care what that circle is, but this here is my my geometry that is kind of like my pickup. Then we can talk about where we're going to pick up the part on the machine. Now in CAD, it doesn't really matter where it is because we're going to do a setup. But what I'm going to do now is I'm going to create a joint, and I'm going to place our origin right on top up here. I'm going to create a joint, so select a joint for this part here from the center here to the center of our circle. See how I select our circle? And just like that, the part get moved down so the origin is sitting right on the top here. But more important maybe for me, I also got that dang angle I gotta deal with. Well, because I'm using the rigid joint, I can actually also control that right here. So I'm just gonna go over here in the window over here, do minus, because I can see it goes the minus way, Control V to paste whatever I copied from that measurement I did before. Hit enter, and this part is now locked in space. Okay? I hope this makes sense. I hope this is good. Enough of all the CAD. Let's get into CAM. This is just important when you are working in in a CAM environment that you know about some of these different tricks. So let's cam this guy up a little bit. So I'm going to go back into CAM environment, and I'm going to create a setup. Now, we place the origin up on top, but this is not really important. What is important in CAM is this here. And if you are unsure about this whole thing, send me an email, lars.christensen@autodesk.com, and I send you a bunch of videos on this. I always use select Z-axis and plane. I'm going to select on the top face here. You will see that it jumps over and shows the Z-axis going up. I'm not a big fan of my X-axis direction, so with that active, I'm just going to select this line here, and it rotates it around. This is my G54, friends. Now, the stock shows up as a rectangle. I would use a round one. So I'm going to go here and click stock, click the drop down. I'm going to select relative size cylinder. Make sure you check what stock is left. It's leaving 1 millimeter on the outside diameter, but the thickness is all finished. That's what I would do also. Okay? All good. I'm going to hit OK to that, and I've just defined my stock. Now, let's throw some toolpath on this first operation. So, I already kind of like showed you before what I would do with the curved surface. So let me just, I would probably start out with the center first, but just because we already talked about the curved surface, I would use the scallop toolpath. If you have never used 3D toolpath, just follow my steps here. Select the toolpath, select the cutter you want. I'm going to go down to the tutorial metric one down at the bottom. I am going to select a 6 millimeter ball end mill. I'm going to hit OK to that. And here's the trick. If you never used 3D CAD before, don't go in and change all kinds of settings. Just hit OK and see what the toolpath gives you. And this actually looks very well. Now, the only thing I notice is you will see scallop collapses. So it goes from the outside and is really, really nice. But as it's getting towards the center, it sees that edge there, and it kind of starts following that round key shaft. And I actually don't want that, a teardrop, whatever you want to call that. I really just wanted to go up to the edge here where that swoop surface ends. So, right-click, edit. Now, the first tab is always the tool. Second one is always selection. So here, hit the machining boundary, click selection, and I'm going to select my two boundaries, this edge and this edge. That's what I wanted to stay within. I'm going to hit OK. And that there is probably exactly what I want, except I know the step over is wicked big here. This would never make a pretty surface. Now, I've said before, the step over comes down to two things. How nice do you want a surface? How much time do you got? So I would say I would never do anything bigger than a half a millimeter on something like this here. So that will do for that swoopy surface right there. Now I know we're coming up on the half an hour, but just almost done. Even though we have two operations, we're gonna kind of like cheat a little bit here. Now, so this is good. I'm happy with this. I think this looks pretty dang good. Now, for the slot in here, I am going to use a 2D adaptive clearing. Again, the tool is the first thing we always select. Go down to my metric tutorial. I am going to select a 10 millimeter flat end mill, because that's the flat end mill I have here. I think maybe fit okay. I am going to click geometry, and I'm going to select that bottom edge. Again, I'm going to hit OK, see what we get here. Looks pretty good. Now, I actually probably would drill a hole first. And if I drill the hole first, well, let's just drill the hole. Drill a hole. Select the drill. Now, let's just assume that this drill is not 118 tip. Maybe it's 120, so we don't have to pre-drill. Though that is, oh, dang, it is 118. All right, I'm going to cheat with that. So I'm going to select the drill here, 10 millimeter drill. Hit OK. Select this cylindrical as drilling through. On the depth, I'm going to make sure it drills through it, and I'm going to add a little bit of an offset, a couple of millimeters. Okay, Now, actually now it's coming after our adapter, so just know you can always drag it up, reorder things by dragging, right? Now with this drill, now I don't need to helix in because we already removed the center here. So we can right click, hit edit, go over to the linking tab, change the wrapping to a plunge. So now that looks pretty good. Now I notice that it really doesn't machine. This 10 millimeter is not machining too much into here. So you know what? I'll probably actually pick an 8 millimeter. Now I'm gonna be lazy here because I know that I don't have a 10 millimeter in my library. I'm just gonna edit this existing 10 millimeter to an 8 millimeter. So I'm gonna right click and hit edit. Gives me a chance to show you the nice enhancement that the developers added this month. We got a nice view so you can better understand what everything is. Change this to 8, so it's going to be a little bit smaller. Hit yes to that. Hit OK. Hit OK. And that there looks pretty good. I think for roughing this out. Now, this is just a roughing operation though. So I'm going to finish that. Now, if I click the inspection tool, you will see that I made these radiuses 2 millimeters, so a 4 millimeter end mill to go 14 down. That's gonna gouge these corner. I talked about gouging last week. You normally always want to cut corners if you're machining it with a smaller end mill than the corner radius. But I mean, we're getting really small here, so I want to show you another trick. I'm going to do a contour and select a little bit smaller end mill. This is not really too important. We have a 5. Select the bottom edge here. So this is our finishing tool path right here. Okay. Now I want to show you a little trick here. So if I just simulate this for a second, and let's turn tail, let's turn stock on. Let's just fast forward down to the contour toolpath here. Let the computer catch up. Now this looks very rough here, but remember how close we are looking at this right now. Oh, I gotta go a little bit deeper with my roughing, with my adaptive. But what I wanted to show you here with this finishing toolpath, and I don't know if you can see it. It's maybe hard to see. There's a little bit, because this is a 4 millimeter radius, we're using a 5 millimeter end mill. It leaves a little bit of material here. Now, if I'm using a 4 millimeter end mill right here, it's definitely going to chatter. It's not going to be great. Another trick, and I'm not saying this is maybe, I mean, the best thing would always be use something else, broach it, YADM or whatever. But you can actually also successfully, I've done this, drill it with a 4 millimeter end mill. So if you go and you select a 4 millimeter flat end mill, the same radius as the corner, but as a drilling operation, and you select these two here, and then if you go over on the passes tab, you can do like a very small kind of like chip breaking. So the cutter kind of like just goes down, just very small steps down. You can actually successfully get to a point where this cleans up fairly nice. Another option is to talk to the customer. If you can do like Mickey Mouse ears, or you know, put something bigger in there, all that stuff. Many times designers just throw a radius in here and they don't have no idea how hard it is to make on the bit. Why not use a drill bit? Because it would wander off. Because the chamfer or the cutting edge on the drill would literally bend off. In this case, with a flat end mill, I could have, well, I should say that I could have drilled it beforehand, but then the drills many times wander a little bit too. In this case here, you get some of the nicest you could get if you don't have, you know, any other means. Just an idea. Okay, I'm already running over. It is the last one of the year though. So I'm gonna say that this year kind of like takes care of my first, oh, let me just, the adaptive here didn't go all the way through. Why didn't the adaptive go all the way through? Well, because we have stock to leave on radial and axial. So we could actually just go in here and change that to 0 for that, and that would make sure that it now cuts at least till 0. Or you can go ahead and height tab and make it a little bit deeper. Okay. Second operation. Second operation here. So now I'm going to take my blank, this one, right, that we just machined. I'm going to flip it over, and I'm going to drag it down on my little fixture that I created here. Whoops. Right? I'm going to drag it over here and screw a screw in, and then I have this here. Now, this is the finished. So with this here, I am actually going to bring in the customer file into this our cam file. So what I'm going to do is I'm going to go out to cam, or out of cam into model. I'm going to hide that first operation that we created there. Now I'm going to go and actually grab the customer's file, the Sprocket, the one we modeled up yesterday, right-click and insert that into current design. Because remember, the link components in here, if the customer should make a couple of changes, I can just update everything. So I'm keeping it in two different kind of files. This is our machining file. So I'm bringing this one in. Now, this one came in not upside down over on the view cube because we changed our view, right? However, it is not sitting the same place as our other one is. If I turn my first operation on, we got to bring the sprocket down here, right? So I'm not using the move, so I'm just going to hit OK to that. I'm going to do exactly what I did before. I'm going to go and click Joint, right? And I'm going to again select the center of top of the sprocket. I'm going to select my little sketch ring I created. It's going to go down there. Now remember that this one was also crooked because the way that our designer modeled it up. Minus, I still have it sitting in memory, Control V. There was that rotation there. Okay. So I have two different files in the same file. My operation 1 and now the finished part that I need for the customer. Okay. Hope this is useful. So let's just wrap this one up here. Now here comes something cool. Let's get back into cam. When I get into cam, you will see that because I made these changes, we have red warnings on all these toolpaths. Doesn't mean that these toolpaths right now are bad. It just means that the software saw we made a change. Now, what I can do is I can just click on and hold down Shift and select all these operations from the first operation. I'm going to right click on it and I'm going to say I want to protect them. That means that now are all completely locked, right? And when I regenerate my new toolpath for my second setup, that these will not be messed with. We have already determined these are great, these are good. That's good for first operation. So for second operation, I'm just going to create another setup inside of this file. Setup number 2. I'm pretty much going to do what you saw me do before. I'm going to select that same faces, place it there. I'm also going to go ahead and do the round stock because that's actually still the same. So now our second setup. Now here's a cool thing. Remember all the work we did to create this toolpath? Well, I actually want that for when I flip the part over for the second toolpath also. And they're sitting in the same spot. So what I can do for my second operation, right click on the first one, say copy, click on our second toolpath down here, right click and say paste. And if I hit the little arrow down here, we just copied that first toolpath down here. We just reused what we had. You know, I said it before. It just always makes it a lot easier, you know, when you can be lazy in CAD and CAM. So now we have our first toolpath. This T-slot is already figured out. We just got to do the last toolpath here. Now, I would rough this out with a 2D adaptive again. And one of the things that is, even though that this is curved, then 2D don't care. 2D is awesome. So I'm going to say 2D adaptive clearing. I am going to select, well, now it became our 8mm drill to do it with. Could probably go a little bit different. Now remember that what adaptive does is, gotta select what you're gonna machine. So I'm just gonna select this edge here. What adaptive does is it looks at that chain I just selected, the stock I specified, and it finds to remove all that material in the most gentle way you can. Now I'm actually going to go into this offset and just bring the cutter a little bit past that, because I know that I have a little bit of you can go a little bit deeper, 3mm maybe, so it goes past the bottom down here. Remember how I kind of like created a little bit of a shelf for that to sit on? Okay, so that's my adaptive. I am going to go ahead and do a finishing toolpath. So that would just be a standard 2D contour. So even though that I'm selecting on a curved surface, Fusion is smart enough to make it flat for a 2D. I'm going to do the same thing as I did before. Just bring it minus 3mm on the depth. Okay. The last tool. So now we got this. We got a roughing toolpath and we got a finishing toolpath. Okay. The last thing I'm going to do here is I'm actually going to go in and I want to deburr this on the outside. We talked about deburring a couple of Fridays ago. Put a little chamfer on it so it's not all going to cut my hand, at least on one side. Then you could flip it over and run that same toolpath one more time. For that, be aware of trace. Now, as it says here on the screen, trace machines a longer contours with varying C values and with or without left and right side compensation. So I'm going to select trace. I am going to go in and select the tool. I'm going to select a 90-degree spot drill, spot mill here with a little chamfer on. I am going to select that upper edge because that's what I want to chamfer. And then I can go over to the passes tab. And it's right now cutting on center, but if you just flip it to the left, so it's on the left side, I'm milling around, and then you will actually see down here that it knows that this is going to be a chamfer toolpath. So I can say I want a little bit of width, and I normally actually leave this on 0 and adjust it in the compensation out of my machine. But I maybe want the tip to go just 1mm past wherever I touched it off. Hit OK, and we now have a tracing toolpath. And even though that it exists under the 2D toolpath, it will actually go, if we simulate it, it will actually go in the 3-axis. It would actually go up and down in the Z-axis, just like you would think that it should. So that was what I knew I was going to go over a little bit today, but I'm going to use the excuse that is the last one of the year. I hope that you got something out of this, at least, you know, if nothing else, food for thought on how you possibly could machine a sprocket like this with hopefully some useful tips. I see here that I might have some streaming issues. I'm sorry about that. It says here my YouTube is not receiving enough video. This will be up. The recording will be up on the screen. So if you have issues, I'll make sure that it gets up there. Oh, now it looks like the stream health is good again. I hope that it wasn't too blurry or too bad. Just chopping up. I'll take a look at it, and I'll make sure that we get the original video up if this is too bad to look at. I hope that's it. That's all I had to show. It's